Hey everyone, welcome back to another physics past paper video. Today we're going to talk about a multiple choice paper from the May-June 2024 from variant 1-3. Now before we jump into the paper, some resources that we have developed, you can see the link below. The grade booster pack, I've been using these in multiple videos over in this particular playlist. Just to show you once more what we have. For A2, we have derivations. We know we get a lot of derivations for gravitational fields and electric fields. Definitions and formulae for A2. So this is a list of important terms, definitions, and their formulae. Graphs, we know we all struggle with the field and the potential graphs for gravitational fields and electric fields. Then we have frequently examined questions for paper 4. As you can see, we have structured it that you have syllabus on the left hand side, question and answer on the right, and then on the rightmost are the years. So there will be some questions where you see a lot of years. Although this is not very comprehensive, but I did try to, add a lot of years. This is the AS definitions and formulae. This is the one that we'll be using in this video. This is the reasonable estimates of table. Then we have AS important definitions, the definitions that come in exams and we are expected to know. Frequently examined questions. This is right now focused on paper 2, but maybe in the 2026 version we will include the paper 1 questions also. Then we have paper 5 planning question worksheet, which includes a checklist and some worked examples. And once again, they're all available on Patreon. So link as you can see below. All right, so let's see this paper. What is equal to 0.0005 joules? So basically what you can do over here, we need to standardize it. We need to have a standard form for this. So let's count zeros. So 1, 2, 3, 4, 5, and 6. So 5, 10 raised to power minus 6 joules, which is 5 microjoules. C. The measurement of a physical quantity may be subject to random errors and to systematic errors. Which statement is correct? So random errors are the errors above and below the true value or both sides of the true value and can only be reduced by taking a mean of those values. Just reduce, not eliminated. And systematic errors can be eliminated once you figure out what's wrong. So it introduces a consistent and constant bias in those readings. So which statement is correct? A systematic error cannot be reduced by adjusting the apparatus. It can be reduced. So this is incorrect. Systematic error results in a different reading each time the measurement is taken. Now that's the quality of random error. Random errors are always caused by the person taking the measurement. No. And random errors can be reduced by taking the average of several measurements. Yes, that is correct. The Young modulus of the material of a wire is to be found. The Young modulus E is given by the equation shown. The wire is extended by a known force and the following measurements are made. Which measurement has the largest effect on the uncertainty in the value of the Young modulus? Right, okay. So basically we need to see that the major effect on the percentage uncertainty, because this is a quotient product and the quotients of things, so we need to see which quantity will have the most effect. So you have the fractional or the percentage uncertainty in the force, then you have for the L, then for the D you have it twice, and for the X. So basically we need to figure out what's the percentage uncertainty for all of them. So 0.002 divided by 2.043, this is the right, times by 100. Let's do it in percent style. So this is 0.097, a very uh, small amount. Let's call it 98. Then you have 0.54 times by 0, sorry, no, divide, sorry, my bad, 0.02 divided by 0.54 times by 100. So this is 3.704. And this one, 0.01 divided by 19.62 times by 100. This is going to be 0.0501. Sorry, I think we can just say 1. And for this one, 0.2 divided by 5.2 times by 100. This is 3.8%. 3.85%. These are all percent. Now, remember D, this component is double because of the square over here. So the diameter and x, although x has a higher percentage, but once you double this, this would become, we could have done this in the start, in fact. So divided by 0.54 times by 100 times by 2, this would be 7.4%. So this has the largest effect on the percentage uncertainty of E, so diameter of the wire. Two physical quantities combined together as a product can produce a scalar quantity or a vector quantity. Which product of two quantities produces a scalar quantity? So this happens when you have a scalar times by a scalar. And if you take dot product of two vectors, that's when you get a scalar. So scalar times by scalar, speed times by time, that equals distance. Force times by force dot displacement would get us work. This is the work thing. This, although if this had been speed, then it would have been scalar. This, however, makes up displacement. The diagram shows the velocity time graph for an object moving in a straight line. What is the displacement during the last 2 seconds of the motion? So last 2 seconds of the motion, we need the area under the graph for this thing. So this is a trapezium, so half times by 6 plus 12 times by 2, so 18. So basically just 18. Okay, a block is moving along a horizontal frictionless surface. The constant force F and a constant force of 5 newtons act on the block as it is moving in the direction of force F. Right. Okay, the graph shows the variation with time of the momentum of the block. What is the magnitude of the force F? So remember, force is the rate of change of momentum or average change in momentum over time. So the change in momentum is 1.5. Okay, so this is going to give us the resultant force. So remember that. So 1.5. So because this is the later thing, 2.7 divided by 0.4. So this is giving us 1.5 minus 2.7 divided by 0.4. So the resultant force is minus 3. So sum of force is equal to, you see, F minus 5, E, and that is equal to 3. So F would be 5 goes on this side, So this would be 2 newtons. So 2 newtons. Newton's third law describes two forces that are equal in magnitude and form a pair. Which description of two forces in such a pair is not correct? So remember, they act in opposite directions, they act on different objects, they are the same type of force, but since they are acting on different objects, one object is not undergoing the two forces. So it's not a necessity that the object is in equilibrium. Because, so for example, you have an object on the ground, it's exert, sorry, no. Although the object has a weight of its own, but the contact force over here, the ball is exerting the force on the ground and the ground is exerting the force on uh, the ball itself. So if you just consider the ball, the weight is going downwards and the reaction force due to the uh, ground is upwards. So the sum of these two, W minus R, that is equal to 0. So you can say that R is equal to W, which means that the force exerted by the ball on the ground will also be equal to weight. So that is the reasoning. So it's not necessary for the object to be in equilibrium. The graph shows the variation with time of the speed of the raindrop falling to the air. Which statement is correct? Right, so if the speed is decreasing, so you can see the acceleration decreasing to 0. So acceleration is decreasing to produce a steady speed. That is correct. Which statement about a perfectly elastic collision between the two objects is correct? Total kinetic energy is conserved. So kinetic energy is conserved and the momentum is conserved. So total kinetic energy is conserved, but okay, so we have the relative speed of approach. So relative speed of approach equals the relative speed of separation. I think the first one is correct. Yeah, so total kinetic energy conserved and the law of restitution applied. Okay. The diagram shows the view from above this. Wait a second. Okay. The diagram shows the view from above of a sprinkler system used to water a garden. The sprinkler consists of a tube of length 0.15 meter, and the tube is pivoted in the middle and spins in a horizontal plane as it lets out jets of water from each end. The two water jets are in opposite directions to each other. Each water jet exerts a horizontal force of 3 Newton on the tube at right angles to the tube. Okay. What is the magnitude of the torque of on the tube from the water jet? So basically this is the torque of a couple. So force times by the distance between them. So force is 3 times by 0.15. So 0.15 times by 3, this is 0.45, which is going to be C. Okay. An object is held in equilibrium by three forces. Forces all act in the same plane. The diagram shows two of the forces that act on the object. But the third force is missing from the diagram. What is the third force? Okay, so it's basically you have to remember that it's just the addition of forces that come into play. So you have 43 Newton like this, and 17, let's say you can add it over here. So this angle is 125, so this angle would be 180 minus 125, 55. And the other force, since this is in equilibrium, so it should be directed towards the tail of the 43 Newton force. And so what we can do now is we can use the cosine rule and the sine rule to figure out the magnitude also. So if we look at the options, this is the only one that makes sense given the direction, but just to be thorough, let's use the cosine rule. Uh, let's call it force F. So force F squared would be 17 squared plus 43 squared minus 2 times by 17 times by 43 times by cosine of 55 degrees. So square root 17 squared plus 43 squared minus 2 times by 17 times by 43 times by cos of 55. This is going to be 36 newtons. So B is the right answer. Okay, moving on. The total number of forces acting on the object is 2. The object is in equilibrium. Which statement about the forces are correct? So if the total number of forces acting on an object is 2 and the object is in equilibrium, so the two forces must have equal magnitudes. They must act in opposite directions, so this is going to be incorrect. Two forces must act to the same point. This is going to be correct. So 1 and 3 would be B. Okay. The diagram shows the atoms in a particular cell. Each atom is at a corner of a cube. Okay, so this is a question that irritates a lot of questions. So this has been going on 2012. I think it came in 2019 also. So although it's not a very frequently examined question, but this does it is a painful and irritating question. So the mass of each atom is this, and the density of the crystal is this. What is the shortest distance between the centers of the two adjacent atoms? Okay, so one thing you need to see this over here is that every corner atom over here is shared by how many unit cells. So for example, this is a unit cell, this is a unit cell, this is a unit cell, this is a unit cell. So as you can see this, like from the top over here, like this pink one is shared by 4. But if you stack another 4 over here on the top, if you stack another 4 over here, this will be stacked by 4 more cubes. So that means every atom is shared by, every atom is shared by 8 unit cells. That means in every unit cell, the total number of atoms effectively, like the effective mass that we are actually counting them, 8 corners of the cube, 8 corners times by, since it is shared by 8, so 1/8 of an atom from every corner. So basically one atom per corner basically. So one atom is effectively just present in one unit cell. So now we need to know the volume of each unit cell. So to find out volume of a unit cell, we do mass per density. So each unit cell has one atom. So mass of an atom, they have given it as 3.5 10 raised to power minus 25 kg, and density they have given us to be 9.2 10 raised to power 3. So 3.5 divided by 9.2 times by 10 raised to the power minus 25 minus 3. This is the volume of a unit cell. So this is the volume. So the length would be the cube root of this volume. This would be the cube root of this value, 10 raised to the power minus 29. So cube root of answer is going to be 3.36, 10 raised to the power minus 10 meters. So let's see which answer is coming close. Minus 10. So minus 10 is this, and 3.36 is, yes, okay, rounded to 3.4. That is correct. Okay. 4 measuring cylinders are filled with the same liquid to the heights shown, at which point is the pressure greatest. So remember, the pressure is equal to rho g h. H is the depth from the height of the column. So at over here, the pressure is virtually 0. Over here, the height of the column is 20 centimeter, and over here again the depth of the column is 0. Over here the depth of the column is 10. So B is the only place where the depth of the column is, up till that point, is the highest, largest. B. In many different filament lamps, as much as 92 joules of energy is emitted as thermal energy for every 8 joules of energy emitted as light. What is the efficiency as a percentage of electrical energy converted to light energy? So 92 plus 8 is 100 joules, and 8 joules is converted into, so I don't think we have to do anything. This is just 8%. What is the unit of power? So watt per time, work done per unit time, or energy per unit time. So joules per second. So 16 is D. An object is in uniform gravitational field. The graph shows how the change in gravitational potential energy of the object varies with distance x moved by an object from the fixed point. Which graph shows how the gravitational force F acting on an object varies with distance x? So gravitational force F would be the same because the mg part will not be changing. So only the x part is changing, which is going to be affecting this thing. So this would be C. A block of mass 2 kgs is released on a slope. It travels 7 meters down the slope and falls a vertical distance of this. A block experiences a frictional force parallel to the slope of 5 newtons. What is the speed of the block after falling this distance? Okay, so in the last video we discussed about the inclined planes. So first off, we need this angle. This is the weight, this is the 2g, so the component of the weight parallel to the inclined plane would be 2g sine theta, and frictional force is obviously opposing the motion, so 5 newtons. So first off, we need to know speed of the block after falling this distance. Right, okay, so you can find out the acceleration. So 2g sine theta minus 5 Newton is equal to ma 2a. We need to find out a first. So 2, 9.81, sine, as you can see, it is 3 over 7. And minus 5 equals to 2a. So 2 times by 9.81 times by 3 divided by 7 minus 5, and then divided by 2. This is acceleration is 1.7049 meters per second squared. The object is falling to this, and acceleration is this. It's falling from rest, so 2as V squared would be the answer because U squared is 0. So, so V would be, oh sorry, square root of 2 times by 1.704 times by 7 whole under root. So we are going to do 2 times by answer times by 7. So 4.884, that is our option A. All right, so two wires, one made of brass, the other of steel, are stretched in an experiment. Both wires obey Hooke's law during the experiment. So Hooke's law just simply means that your force and extension are directly proportional. That means straight line. The Young modulus for the brass is less than the Young modulus for steel. Which graph shows how the stress varies with strain for both wires in this experiment? Okay, so right. Okay, so we are talking about the straight line region because it's obeying Hooke's law, so we are dealing with a straight line. So right off these two are cancelled. Now, Young modulus for the stress strain graph is the gradient of stress strain graph. So the gradient, the Young modulus for brass, so that means the gradient for brass would be lower. So gradient for brass is lower. B is the right answer. A sample of material is stretched by a tensile force to a point beyond its elastic limit. The tensile force is reduced to 0. The force extension graph is shown, which area represents the net work done on the sample. Okay, so that would be y minus z, because up until this point, like when you reach this point, the work done would be x plus y, but the energy or the work released back is the area under this, that is minus c. So net work done is x plus y basically. Sorry, no, x plus y only, because sorry, when I wrote y over here, I meant this complete thing. So y plus z. So x plus y would be the right answer. A wire is fixed at one end and is extended by a force F1 acting on the other end. So it's fixed at one end and it's extended by force F1 and acting on the other end. This causes the wire to have elastic potential energy of 0.15 joules. The force applied to the wire is now changed to force F2. This causes the wire to have a new elastic potential energy. Okay, the wire obeys Hooke's law. Obeys Hooke's law, that means it's basically under the straight line region. So this is your force, this is your extension. So whatever we have under this. So there is a force F1, and then there is force F2. X1, X2. So area under this part was 0.15 joules, but when you go to F2, that means this entire thing, including this thing, would be 0.6 joules. Okay. What is the relationship between F1 and F2? So basically, we need to see how this works. It's a straight line, basically, right? So we need to see, obviously, the triangles are similar because they have the same proportions. So area 1, area 2. let's take a ratio between them because we need an answer in the form of ratio. So half f1 x1, and this is half f2 x2. We don't know anything about the x2. We only know about the area. So this is 0.15 ratio 0.6 joules. So what we need over here is we need to figure out how or where the area would go. So first off, we can find out half times by what is the relationship between the area. So 0.16 divided by 0.6 divided by 0.15. So 0.6 divided by 0.15, that is 4. So this means this area, fx2, this is 4 times by this. 4 times by this. However, since this is along the same straight line, your y is equal to mx is basically f is equal to kx, the gradient is the same. The gradient remains the same. So we just need to see where you are getting this value. So according to this, if you double the force, you will have to double the extension also. So to have a net effect in the half fx times by 4, you will actually be doing f times by 2 and x times by 2 also. So the net effect is 4, so area 1 times by area 1 times by 4 is equal to area 2. So the net requirement is that you're doubling both of these at the same time. So that's why f2 is twice of f1. The diagram shows a representation of a wave on a screen of an oscilloscope. The Y gain is set to 3.5 millivolts. What is the amplitude of the wave? So remember, amplitude is basically half of peak to peak. So peak to peak is, actually you can see that amplitude is 2 also, because again, peak to peak divided by 2. This is where the mean point is. So 2 times by 3.5, so that is 7. A transverse progressive wave on a string has a wavelength of this, amplitude of this, the speed on the wave on string is this. What is the distance traveled by the point on the string in a time of 2 seconds? To understand this, you need to recall how the displacement time and the distance displacement function works. So this is the distance graph, distance time, or distance, whatever you want to do with that. So displacement distance gives us the wavelength from points in phase, but distance time gives us time period. So right, so wavelength between the 2 points is 12 centimeter, but we do not know the time. So for example, if we are doing this, we don't know the time. So for time period, what we can do is distance over speed. That is exactly how we actually go with or derive the v is equal to f lambda. So wavelength is 12, speed is 48, so that means 1/4 of a second, which means frequency is 4 hertz. That means 4 waves in 1 second. Now, the object The amplitude is 1.5. So remember, in one wave, it is going once upward, downwards, then up. So 1.5 going upwards, then 1.5 going downwards, then 1.5 going downwards, then 1.5 going upwards. So in one wave, it is traveling 6 centimeter. So how many waves do we need? So 2 divided by 1 divided by 4, or 0.25, this is simply 8. So 8 waves, basically 8 complete waves. So 6 times by 8, that is going to be 48 centimeters. Sorry. Okay. An ambulance siren emits a sound with a single frequency F. The ambulance travels towards, passes close to, and then travels away from the stationary observer. So basically, if this is stationary observer, this is how the ambulance goes. Which statement describes the frequency of sound detected by the observer as the ambulance passes the observer? So as it's closing in, the frequency will will be higher than this f, and when it goes away, it decreases from the value f. So equal to f and decreasing. So as it passes the observer, equal to f and decreasing, equal to f and increasing as the ambulance passes the observer. So passes the observer is basically this point. So equal to f and decreasing. That would be the case. An electromagnetic wave has a wavelength of 138 picometer in a vacuum. To which region the electromagnetic spectrum does this wave belong? All right, so just to show you the wavelengths, this, although you should have some idea, but if you are not familiar with this, we have the, is it in this? Okay, so we're looking for, so these are wavelength ranges. So this is in gamma. So pico is less than this. Pico is 10 raised to the power minus 12. So it will be in gamma. So oh, there is no gamma. Okay. X-rays. Right, right. Oh, sorry, I forgot. This is 138. So 138 picometer. So figure out how to bring the decimal from here to here. So divided by 100 times by 100. So this becomes 1.38, 10 raised to power 10 meters. So this is definitely in X-ray. We already saw this over here. So X-rays is over here. Right, my bad. A student investigates the polarization of microwaves. The microwaves from the transmitter are vertically polarized. The metal grill acts as a polarizing filter when placed between the microwave transmitter and receiver. The reading of the voltmeter is proportional to the intensity of microwaves emitted through the grill. When the transmission axis of the grill is vertical, the voltmeter reads 3.5 volts. The grill is then rotated through an angle um, theta. The voltmeter now reads 2.2 volts. Okay, what is theta? So basically, you have I naught cos square theta. Now the reading on the voltmeter is proportional to the intensity. So basically, this is approximately will have the same relationship as this one. You establish the proportionality. and this will actually lead to this. So you have now 2.2, starting value was 3.5, cos squared theta. So cos squared theta would be 2.2, 3.5. And then um, first off, you would need to do the square root 2.2 over 3.5 and then do the cos inverse. So cos inverse of square root of 2.2 divided by 3.5. So this would be 37.5. So this is A. Two waves superpose, which a resulting wave pattern is formed. Which statement about the two waves must be correct? They have the same amplitude? No, that is not necessary. They are of the same type. Yes, that is the only thing that's necessary over here. So for superposition to happen, they must be of the same type. Transverse, transverse, longitudinal, longitudinal, sound wave, string wave, water wave. So the waves have to be of the same type. A water wave passes through a gap in a harbor wall and diffracts. The gap has a width of 8 meters. The wave travels directly towards the gap. For which wavelength is the diffraction of the wave greatest? So remember, when the gap or the aperture is approximately close to the wavelength, that's when the diffraction would be greatest. So 28 would be D. Light of wavelength 5.5 10 raised to power minus 7 meters from a laser is incident normally on diffraction grating. The diffracted light is incident on a semicircular screen. Right. The total of bright 9 dots are formed on the screen. The grating is the grating is at the center of the semicircle. The lines of the grating are vertical. The separation between the adjacent lines in the grating is D. What is a possible value of D? Okay, so remember, total of 9 bright spots would mean that you have one zero order over here. Then you have 1, 2, 3, 4, 1, 2, 3, 4. So 4, 3, 2, 1, 1, 2, 3, 4. So that means at the most you are looking at fourth order. So n is equal to 4. So n lambda is equal to d sine theta. So so fourth value, like the fourth value, uh, so at basically sorry at sine 90 it would be 4 point something, but rounded to an integer it would be 4. But what is the possible value of d? So if we do d, uh, let's put 90 into the theta, so 4 times by 5.5 10 raised to power minus 7 divided by sine theta, that is just sine 90, that is just 1 basically. So we need to see which value of d comes close. So 4 times by 5.5 times by 10 raised to power minus 7. So once you do the standard form, this will be 2.2 minus 6. So minus 6, 2.2, that is the first one. Which quantity is given by the product of charge and potential difference? So remember, potential difference definition is work done over charge. So potential of charge and potential difference would be work done or energy. So energy transferred, that's it. The current in the filament lamp is increased. Which statement about the lamp is correct? Brightness of the lamp decreases. Wait, no. The current is increased, so brightness would increase. Potential difference across the filament decreases. No. The resistance of the filament decreases. Also no. because the resistance will increase because the temperature increases. So remember the Ohm's law that we study, V proportional to I, assumes that the temperature and other external physical quantities are constant. So that's why there is a non-ohmic uh, response on that. So what we expect over here, so the current in the lamp is decreasing, so you will increase, it would be somewhat like this. So how do we know that we are doing the right thing? So as you increase the current, or as you increase the potential difference, resistance is rising. So in the graph of IV, as you can see, the more you increase voltage, the current is change in current is decreasing. So resistance will increase. Okay. Student builds the circuit shown. All lamps are identical. Which lamp dissipates the most power? This would be straightforward part D. Why? Because the Kirchhoff's first law tells us that when there's a current branching, the current will decrease, and the current entering will equal to current exiting. So that means this current is equal to current flowing through this D. So I squared R tells us that the maximum current flowing through the same amount of resistance will dissipate most amount of power. So D is the correct one. Okay, so the resistance of a metal cube is measured by placing it between two parallel plates as shown. Cube has a volume V made of material with resistivity rho. The connections to the cube have negligible internal resistance. Which expression gives the electrical resistance of the metal cube between X and Y? So this is a metal cube, so we need to find out the cross-sectional area. So V is basically uh, L cubed. So L squared, on the other hand, what would be the cross-sectional area? We can easily figure out. So L is basically cube root of V, or V 1/3. So L squared would be V 2/3. So we need the electrical resistance, so this would be rho L over A. So this is rho L is basically V 1/3 divided by V 2/3. So we know the laws of indices. So this is going to be 1/3 minus 2/3. 1/3 minus 2/3 is basically minus 1/3. So rho V minus 1/3, which would be rho divided by V 1/3. So this would be C. A circuit needs to be completed by connecting two resistors between points X and Y. The resistors can be connected in series or in parallel with each other. Which combination of resistors produces the least resistance between X and Y? Okay, so remember the rule. When you place resistors in parallel, the net resistance would be lower. But when you place them in series, the net resistance would be the sum of these two. So that means if you have R and R2, and this is R1, R2, so the effective resistance is basically R1, R2 divided by R1 plus R2, which would be lower. This one will just simply R1 plus R2. So we need a lower value. So that means we need to figure out which one of them we need. So parallel would be the case, but which one of them will give us the lower one? The answer is very straightforward, but let's use this formula to check. So 20 times by 40 divided by 20 plus 40, and you have 40 times by 100 divided by 40 plus 100. So this is 800 divided by 60, and this is 4,000 divided by 140. So I think the answer is staring us right in the face. So 800 divided by 60 is 1.3, sorry, 13.3, and 4,000 divided by 140 is 28. 29, let's say. So the lower one would be this one. So when in doubt, use test numbers. The diagram shows a circuit that includes a cell with internal resistance, with the switch is initially open. Which row describes the effects on currents I1 and I2 of closing the switch? So when switch is open, I1 is equal to I2 because there is no other path for that. But when it is closed, I2 would be less than I1 because I1 would be uh, sharing this. So I1 would be actually equal to I2 plus I3. So I now we need to figure out what's the net I1. We are increasing the resistance by a small amount. So you have R, let's say R again. So series, sorry, no. You are actually decreasing the resistance, my bad. So if those are identical, do we know that these are the same? No. So series, so they are connected in parallel, so the total resistance would decrease. So that means the net resistance would decrease. So if the net resistance decreases, current would increase. So I1 would increase because V over R basically is increasing. So that means these two go away because I1 is increasing. Now I2. I2, I2 and I3 would be the same, but definitely I2 would decrease. It cannot be the same because if it stays the same, that would mean that it is higher than I1, so virtual impossibility. Because, right, okay. The if this were not there, then we could use the I is equal to V over R scenario over here. And that would tell us that this would be the same. But since this is there, the net current is being affected, so I2 and I3 would be different. All right, the diagram shows a circuit consisting of a cell and three resistors R1, R2, and R3. The cell has electromotive force 1.6 volts and negligible internal resistance. The current in the cell is 0.6 ampere. Potential difference across R1 is 0.48. The current in R3 is this. What is the resistance of R2? Okay, so you see the potential difference uh, across this entire thing is 1.6. So if potential difference across R1 is this, we can easily find out. So 1.6 divided by 0.48. So this is 3. Oh, no, sorry, minus 1.12. So 1.12, sorry, 1.12 volts is the VR2. 1.12 volts. And do we know the current flowing through this? So we can find out the current flowing through this. Let's call it I2 would be 0.64 minus 0.32. So this would be 0.32 itself amps. So now we can easily find out the resistance of R2 would be V over R. So 1.12 divided by 0.32. So 1.12 divided by 0.32, this would be 3.5. All right. The diagram shows a potentiometer circuit used to compare the electromotive forces E1 and E2 of two cells. X and Y is XY is a uniform resistance wire. The fixed resistance R has a resistance R. Sorry, the sliding contact is moved along the wire XY. When the sliding contact is at position P, the galvanometer reads 0, so null point. The circuit is changed so that the galvanometer reads 0 when the sliding contact is at a new point to P, to the left of P. So, wait a second. Okay. What change could have been made to the circuit? So, what change could have been made to the circuit? Now, given the options given, we are not changing the direction or polarity of E1. All right, so Vxy basically is the E1 minus the IR. Let's call it I1, I over here basically. So IR basically. So the terminal potential difference basically. So the XP would be a fraction of Vxy. Now we're saying that it is reading much earlier. So Vxy basically is, sorry, no, Vxp and divided by Vxy is proportional to length of xy or length of xp divided by length of xy. So now we are saying that xp has been reduced. So if this has been reduced, this has been reduced. This means that Vxp, or this ratio at least, has been reduced. So Vxp ratio Vxy has been reduced. So this could mean one of two things. Vxy has increased. Vxy can be increased by EMF E1 is constant. IR, this component, if it decreases, Vxy would increase. And this component can only decrease if R has been decreased. So, wire XY was replaced with one of lower resistance. No, no. E2 was increased. No, if E2 was increased, we would have needed a larger length. So no. E1 was decreased. No. And R was decreased. R was decreased. Yes. Right. Okay. Nucleus P has 144 neutrons and 93 protons. Nucleus P is unstable and undergoes alpha decay to form nucleus Q. Nucleus Q, it then undergoes beta decay to form nucleus R. Which graph nucleus P is represented by point P? Which point on the graph represents nucleus R? Okay, so remember one thing. When alpha decay happens, mass number is decreased by 4, proton number decreased by 2. So number of, sorry, this is not that. Number of protons, so number of neutrons also decays by 2. So remember that. So neutrons minus 2, protons minus 2. So that would be, no, wait. Number of neutrons would decrease to 142 and proton number decrease to this. So this would be the first due to the alpha, And now we need beta decay. So beta negative decay, one neutron decays into an additional proton. So one neutron decays, but one proton number would increase. So this would be this one, A. The diagrams show the quark composition of four different hadrons. One of the hadrons is sigma plus particle. It has a charge of plus E, where E is the elementary charge. Which hadron could be with sigma plus particle? So up quark, remember UCT has plus 2/3 E charge, and down strange bottom has negative 1/3 E charge. So we have this uh, in the table that we have in the definitions and formulae. So right over here. So up on top have plus 2/3, and down strange bottom we have minus 1/3. So um, we need plus E. So we need to know what combination of 2/3 E plus up charm, and what combination of 1/3 minus 1/3 E will get us times by this can get us this. So this needs to be times by 2, and this needs to be, so 4/3E minus 1/3 E would get us E. So this means that these two need to be 2. So so there is no down and strange. So both down and strange have minus 1/3. Hmm. Oh, there is one possibility. So there are two U's over here, the two ups. So yes, that would be correct. So because we need 2 times by 2/3, so this would be straight away correct. What type of particle is composed of most quarks? Most quarks. So baryons, which are composed of 3 quarks, antiquarks are quark themselves, but antiquark. Lepton is not a quark. Meson is one quark, one antiquark. So B straight away is the answer. All right. So let's hope we have made this easy on you. Let's hope I did not. I was able to explain all of these questions properly. Do check out the resources that we have put in the Patreon. You can see the link below in the video to check it out and ace your grades. All right, so bye bye.